All right, so in the last video, we learned just the definition of the six trig functions of acute angles. Now we're going to wind up taking a bunch of different right triangles and trying to set up the appropriate trig ratio and then go on and solve them. Before you watch the rest of this video, you need to go ahead and get a calculator so that you can work on making sure that you can enter the trig functions correctly in your calculator. Okay, so what I want you to do on these is make sure that you're using the given information. Okay, so don't find remaining sides, don't look for the other angle. All I want you to do is take the information that they gave you and the side that they labeled with the lowercase letter. Take those three pieces right there, and I want you on this to think about SOHCAHTOA and look at that information and decide which trig ratio, which trig function relates those three things. So if this is my angle, I would look at how this little side labeled A, how that's the side opposite the angle, and how the 250 is the side adjacent. Okay, this would have been the hypotenuse over here. Okay, we weren't given any information about that. So if we're going to set up a trig ratio for this one, it would involve opposite and adjacent, so that would be tangent. So you would say the tangent of 37 degrees has to equal the little a, the opposite side, over the adjacent side. So a over 250. All right, now from here to the end, we're actually just needing to use some algebra skills, but sometimes this tangent 37 throws people. TAN is just the name of a function, kind of like the little f you use so much in 112. And so TAN can never be separated from its input. 37 is the input to the function, and tan of 37 is the output. And so you're going to do tan of 37 degrees on your calculator. Okay, now what you want to do is you want to watch the mode you're in. Okay, these problems all are in degrees. So, you've got to look at whether you're in degrees or radians, and you need to be in degrees. On my calculator, I use a TI-30 X2S. It's just right there up at the top left. You probably have a mode button where you can make that change, but make sure that your calculator is set to degree mode. All right, now what I recommend is that you go ahead and get the equation solved for the variable. So see how we would multiply 250 to knock that out? And if we do that to one side, we have to do that to the other. And so the little a winds up equaling 250 times the tangent of 37 degrees. So now it's just some calculator work. Now this problem said round answers to the nearest whole number. So you get to round quite a bit on these. So just take the 250, multiply by tangent of 37. It's important that you do this with me, so you actually know that you can get these things entered correctly and you're not coming up with any incorrect results. And so that would turn out to be 188.388 goes on. If we rounded to the nearest whole number, it'd be about 188. All right, then you look at the unit. It was centimeters. Make sure you include the unit on that. Okay, so 49 turns out to be about 188. All right, let's go through the same process on 50. So you focus on, all right, what was I given? And they wanted me to find this. I look at those three pieces and see their relationship to the angle that they gave me. And again, I've got the opposite side and the adjacent side. So this is going to feel just like the other one did. So we're going to use tangent of 61 degrees, and we're going to put the little a over the 10. Okay, and then the rest of this is algebra, but sometimes I find that's what gets us into trouble, is if your algebra skills are rusty, you can sometimes not do a really good job here. So when we multiply both sides by 10, we're going to get a equals 10 times the tangent of 61 degrees. Okay, so now you're going to go in and just work that out. Do 10 times tangent, and it was of 61, and you get about 18. And this one was also in centimeters. So that would be the answer on this one. Okay. All right, so what I would do at this point is just, let's do it. Well, let's do a few more. All right, let's look at 51. All right, so 51, we have these three parts. We're looking at angle 34. We can see that 220 is the hypotenuse and that the B is the adjacent side. So we have to think of something that involves the A and the H. So that would be cosine, wouldn't it? So we're going to set that up. That would be cosine of 34 equals B over 220. And keep the degree sign on the angle. I think that's helpful, especially when we start working sometimes with radians, to keep straight what mode you're in. All right, let's go ahead and set up all of these, and then you can go in and solve all of them. But let's focus on the setup, because that's the part I really want you making sense of. All right, now this one also had the 34-degree angle, but then it gave us this side over here, which is really the side opposite, and then this is the hypotenuse because it's opposite the right angle. So for 52, you're going to need sine. So it'd be the sine of 34 equals A over 13, and that's 34 degrees. Okay, we don't have to use the parentheses on that, but when I remember to do it, I like to, because I really want you realizing the sine, the cosine, the tangent are just names of specific functions. Okay. All right, now let's go ahead and set up 53 and 54. All right, so you're focused on the parts you were given. Okay, and so you're looking at how little c, that's opposite angle c, which is the right angle, that's the hypotenuse. 23 degrees was the angle you were given, and 16 is opposite that. Okay, so this turns out to be sine as well. So this one's going to be sine. Let me leave a little room so we have room to work these out. This would be sine of 23 degrees equals 16, but this time the variable's in the denominator. So that one kind of messes people up algebraically sometimes. All right, and then the setup on 54, let's look at it. Get back up here. Okay, so let's look at 54. We're being given this angle and these two sides. And so on this one, looking at 44, 23 is opposite it, and this one is adjacent. It's not the hypotenuse, that would have been over here. Okay, so we need something that relates the opposite and adjacent, and that would be tangent. So this one we can use tangent of 44 equals opposite side, which is 23, over the adjacent side, which is the unknown. Okay, so that's the part that really is the trig part, is understanding how to set up those ratios. Now we're going back and doing the algebra part. Okay, so let me go back to 51. So let's finish these up, and you do want to, kind of justify your work, so make sure you're putting in that middle step. Okay, so here we'd have to multiply by 220. So B would equal 220 times the cosine of 34 degrees. And so go ahead and work that out. And that was cosine of 34. Okay, so that one turns out to be around 182. And that is in inches. Okay. Right, and then over here on 52, we'd multiply by 13. So we wind up with A equaling 13 times the sine of 34. Okay. And that gives us around 7.37, since we can round. So let me do a squiggle there since I'm rounding. So that's around 7 meters. Okay. Now, really concentrate with me on these two, especially if it's been a while since you've been in algebra class. I think it really helps to put in a step to really work this out using your algebra skills. You have a problem that has fractions, so let's clear the fraction by multiplying by the denominator. But if I do that on one side, I have to do that on the other. So unlike the others, my unknown isn't by itself right now. I have c times, I'm here, I have c times the sine of 23 degrees equals 16 at this point, okay? Now, sine of 23 degrees is just some number, but I don't want you putting it in on your calculator and then putting in the decimal for it right here. I just want you realizing it's an output that's a number. So you can just divide by that on both sides. Okay. And so that leaves you the c by itself like you needed. So that gives us our c. And then you just need to do this work right here to get your result. So you're going to take 16 this time and divide by the sine of the 23, making sure that you are in degree mode. So you get around 41 meters on that. Okay. All right, so what I don't want is you skipping, like looking at the pattern to determine what that is and skipping the algebra that makes that happen. Just go through the algebra. Get rid of the fraction. So you wind up having b tangent of 44 degrees equals 23. And then tangent of 44 is just a number, so you can divide by it. Since you multiplied by it, you can divide to undo it. Do that to one side, so you can do that to the other, okay? And that'll tell you what b is. So you type in your 23 divided by tangent 44, and you wind up getting around 23.8, so that would be about 24 yards. Okay, and I noticed that it was close to 23 yards, but that's because this 44 degrees means the other angle is like 46 degrees, right? Because all three have to be 180. So these two angles are almost the same size. So that means these two legs have to almost be the same length. Okay, so that makes sense that it was so close to that. Okay. All right, so that's how you determine the unknown in a right triangle. You look at the pieces you're given and you figure out which trig ratio involves those three pieces. Okay, then you set that up and go from there to solve. Use your algebra to solve, right? And then just really be careful and make sure you're watching what the mode is for those. Okay, I'm going to stop this and create another short video dealing with the special triangles.